Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello and welcome to the Oxygen Alliance YouTube channel. My name is Janet Talia, a biomedical engineer working with Global Health Informatics Institute under the Open Rotary initiative. I am with my colleague,
and I am also a biomedical engineer working under the same Open Rotary initiative.
And today we will tear down the DeVilbiss 1025 Oxygen Concentrator, so stay with us.
The DeVilbiss 1025 Oxygen Concentrator has a maximum capacity of 10 liters per minute, and it delivers oxygen with a concentration from 87 to 95.6%. So this model, there are three variants of this model, the difference being the voltage rating. We have the 1025 DS, which is 110 volts AC, and we have the 1025 KS, which is 230 volts AC, and last we have the 1025 UK, which is 240 volts AC. So let us start looking at the external parts of the oxygen concentrator. Make sure you follow safety procedures whenever you are handling medical devices such as the oxygen concentrator. So we have the power switch. The power switch is used to turn on and off the oxygen concentrator. So we also have the flow meter. The flow meter is used to measure and regulate the amount of oxygen being delivered to the patient. Usually, oxygen flow meters are calibrated in liters per minute. We also have a reset circuit breaker, which is also known as a reset switch. So the reset switch is used to cut off electrical current whenever there's an overload or a short circuit. The reset switch pops out whenever there is a fault. So in order to reset it, you need to press it back in. We also have the oxygen outlet port. So the oxygen outlet port is the port where product oxygen comes out. This is the point where you can connect a nozzle cannula or a face mask. You can also use the same oxygen port to connect a humidifier bottle. Moving forward, we also have plant labels. These plant labels used to indicate the do's and don'ts. For example, the first one is used to indicate that you should not smoke near or around the oxygen concentrator. And the last one here is used to tell the user that they should go through the user manual before using the oxygen concentrator. We also have indicator lights. We have three indicator lights. The first one being a service indicator light. The second one being a low purity indicator light. So the low purity indicator light is going to turn on whenever the oxygen purity goes below 85%. The last indicator light is a normal or high purity light. This is a light that will turn on whenever oxygen purity goes below 85%. We also have an hour meter. The hour meter is used to indicate the cumulative hours the oxygen concentrator has run. So let us look at the parts at the back of the concentrator. We have the filter door. So on the filter door is going to give you access to the gross particle filter as well as the HEPA filter. We also have an oxygen auxiliary port. The oxygen auxiliary port delivers oxygen at a flow rate of 2 liters per minute, and it is also used to fill cylinders using home filling devices. And we have the rating label. The rating label is where you find information such as the voltage rating of the device. For our machine, we have a voltage rating of about 220 volts to 240 volts. And lastly, we have the power connection port. So for the 1025 KS and 1025 UK model, they have an IEC power connection. This is the connector.
So this alarm turns on when the purity of oxygen goes below 85%. The onboard sensor on the PCB senses the purity in oxygen, and when it goes below 85, that is when it turns on. So I will turn on the concentrator to show you the alarm. So as you can see, the yellow light has turned on, which shows that the purity of oxygen has gone below 85%. This is accompanied by an audible alarm. And if the concentration goes below 60%, both the red and the yellow LED will turn on, showing that the concentration is too low and that the concentrator needs service. Please note that these alarms will be blocked for the first 15 minutes to allow the concentration of oxygen to stabilize. And in the description box below, there is a link to a video that details how you can troubleshoot for this alarm. So next, I will explain about the low flow or the obstruction alarm. So this alarm turns on when the flow of oxygen goes below 2 liters per minute, or when there's an obstruction in the flow of oxygen. For example, if you're using a cannula and there is a kink in the cannula, it will trigger this alarm. So to demonstrate this alarm, I will first turn on my concentrator. Then I will reduce the flow to 0 liters per minute, which will cause an obstruction. So as you can see, the service indicator light has turned on, which is indicating an obstruction within the system. And to remove it, I'll simply just increase the flow rate to above 2 liters per minute. So with that done, the service indicator light has turned off. So I'll turn off the concentrator. So there are several ways in which you can troubleshoot for this alarm. First, you can check for leakages within your system. If there are no leakages within your system, you may consider checking the flow rate that is set on your concentrator, because it could be possible that your flow rate has been set too low. So therefore you have to set it within the specified range. So if your flow is within the range of 2 to 10 liters per minute, you may consider checking your outlet pressure. And for this concentrator, the outlet pressure is 20 psi or 138 kilopascals. And we are measuring pressure because a wrong pressure setting can lead to mismatched flow meter readings. So next, I'll explain about the high flow alarms. So this alarm is turned on when the flow of oxygen exceeds 10 liters per minute. It is indicated by the service indicator light accompanied by a beeping sound. And for now, I will demonstrate to you the high flow alarm. So I will turn on the concentrator, and then I will set my flow rate to above 10 liters per minute. And as you can see, the service indicator light has turned on, being accompanied by a beeping sound. And to remove this alarm, I will simply reduce the flow rate to below 10 liters. And that is how you can remove this alarm. So lastly, I will explain about the compressor failure alarm. So this alarm turns on when the compressor has a problem and it is not turning on. And as an indicator for this alarm, the service indicator turns on, accompanied by beeping sound. And for this concentrator, we have deliberately disconnected the compressor in order to showcase this alarm. I will now turn on the concentrator to demonstrate this alarm. So you will notice that the compressor is off. And after a few seconds, the service indicator light will turn on, indicating compressor failure.
Having looked at the external parts of the oxygen concentrator, now let us look at the internal parts. So in order to have access to the internal parts of the concentrator, we need to remove all the covers. Firstly, I'll start by removing the filter door. So, to remove the filter door, you need to press it downwards while pulling outwards. And I am going to demonstrate. You'll notice that the filter door contains a gross particle filter. So the gross particle filter filters large particles, for example, dust particles. And we also have a HEPA filter. The HEPA filter is the short form for high efficiency particulate air filter. So the HEPA filter filters fine particles. To remove the HEPA filter, you need to pull it outwards. There.
So to open the back of the concentrator, you're going to use a Torx T25 or a flat screwdriver. And for this back cover, it has got 6 screws. So you have 2 screws at the top of the concentrator, 2 screws on the side, and 2 screws at the bottom of the back cover.
Having unscrewed all the screws, now you can remove the back cover. So you can simply slide it out. Having removed the back cover, we can now have access to the compressor filter, and the heat exchanger. So this compressor, the model name is a ZW600F-130. It has a rated voltage of 220 volts to 240 volts and produces a flow of 135 liters at 1.4 bar. So the compressor has a safety relief valve. This safety relief valve is a safety feature which pops up whenever there's a buildup of pressure above the rated pressure. And we also have the compressor filter. The compressor filter filters air after the compression and before entering into the rotary valve. We also have the heat exchanger. So whenever you are compressing air, the temperature of air increases. Therefore, we have this heat exchanger to dissipate some of the heat that has accumulated in the air. Now we are going to remove the front cover. So in order to remove the front cover, we have 3 screws. 2 right here and 1 at the front. Having removed all the screws, now you can have access to the front cover. When removing the front cover, you need to be careful because there are cables. These are the cables. So now we have access to the front side. We have the rotary valve and sieve beds, as well as the control board. Whenever you are removing the front cover, you need to be careful because there is a wire harness and a tube. So now I'll remove the wires in order to completely separate the front cover from the concentrator. Now we can completely remove the front cover. And now we have access to the front part. We have access to the rotary valve, sieve bed, and the control board. So the rotary valve controls the direction of air being fed into either of the sieve beds. The rotary valve has a stepper motor which is connected to a disc that has circular holes. So as the stepper motor is rotating, it controls the opening and closing, thereby controlling the passing of air to the sieve beds. Now this is the sieve bed. The molecular sieve bed, usually made out of aluminium, contains a substance known as zeolite. Zeolite filters out nitrogen, thereby allowing concentrated oxygen to pass through the outlet.
So moving on, I will explain about the purge manifold. So that is this part right here. And what this part does is, it helps to purge out nitrogen in the depressurizing sieve bed. This part also contains check valves, which are there to prevent the backflow of oxygen from the product tank to the sieve beds. And next, we have the pressure regulators. So the 1025 has got two pressure regulators, one that controls pressure that is going to the patient and one that goes to the auxiliary oxygen port. So this one right here controls the oxygen that is going to the patient, and the preset value is 20 psi or 138 kilopascals. This one over here controls the pressure that is going to the auxiliary oxygen port, and the preset value for this pressure regulator is 15 psi. So next, we are going to remove the compressor in order to access the parts that are beneath it. So to successfully remove it, you are going to need some seal tape, a flat screwdriver, and a T spanner 10 millimeters. So to begin with, you're going to have to tilt the concentrator. To have access to the nuts that are beneath it that hold the compressor in place. So there are 4 nuts that you're going to have to unscrew. So moving on, we are going to remove the wires that are bringing power to the compressor. Then we will unscrew the hose clip that is connecting the compressor's filter and the heat exchanger using a flat screwdriver. So since this is a tube that is leading to the sieve beds, we have to seal it in order to prevent moisture from going to the sieve beds. So we do that using the seal tape. the tube, we will remove the intake tube that is coming from the HEPA filter. And lastly, to remove the compressor, you will have to put this aside and lift it out. So now that we have removed the compressor, we can see that there are several parts that were beneath it. So there is the fan, as you can see, there is the fan which is used to cool the whole internal system and also the compressor. And the fan has got a fan guard over here. Inside there is also the start capacitor, which is used to start the AC compressor over here. So down here we also have the thermal switch, which is used to protect the compressor. So it senses the temperature at which it is operating, and if it is too high, it cuts off power to the compressor. And lastly, we have the outlet muffler. So this is there to reduce the noise that nitrogen may make as it is being exhausted to the environment.
Now, continuing with the disassembly, we need to remove the printed circuit board so that we can see the parts clearly. So in order to remove the PCB, we need to disconnect the cables. So remember, it is important to mark or to take a picture so that you should know which cable goes where. Firstly, I'm going to disconnect the cable for the rotary valve, and this cable is for the fan. This one for the switch, and lastly the AC power that brings AC power to the board. Then I'm going to disconnect the tube from the product tank. You will note that this board is secured by one screw. To remove this screw, I'm using a nut driver and a T15. So when removing the PCB, you need to pull it outwards. So this is the printed circuit board. On the PCB, we have an OSD, in short for oxygen sensing device. So the main function of the OSD is that it measures and monitors the concentration of oxygen that is coming from the product tank. So this is where you connect the tube coming from the product tank, and this tube goes to the flow meter. So whenever the oxygen concentrator has a low purity alarm, it is because it has been detected by this sensor. We also have the power supply. So we have this AC input pins and DC output pins. We also have a buzzer. So this will produce a sound whenever there's a fault or an alarm. So this PCB uses a microprocessor, the STM32. It is located under the OSD. So in order to have access to the microprocessor, we need to remove these two screws using a T10. Now to remove the sensor, you need to slide it outwards. Remember to be careful because you might damage the connection pins. This is the microprocessor. So I'm going to connect it back. You slide it in. Then make sure the screws align. Having looked at the board, now I am going to press it back. So you need to slide it back in its position and make sure the point where you screw in aligns. So I am going to use the T15. So now I'm going to connect the cables. We have this port for the AC power. This port for the fan. This port for the rotary valve. And this port for the switch. Lastly, the tube from the product tank.
So now I am going to explain how power and electrical signals are transferred through the concentrator. So power is supplied through this power supply board, and for this concentrator it's 230 volts AC. So in here we have the live and the neutral wire. So the neutral wire goes straight to this compressor connector, and then it goes back in the harness together with the live wire where it comes out here. So these are the two wires from behind. So the neutral wire goes straight to the board, whereas the live goes to the reset switch. So this is where it is connected. So it is connected down here at the reset switch. And from the reset switch, the power is supplied to the on and off switch. And from here is where it is connected to the control board through these cables. So as you can see, this cable is going together with the neutral wire, which are supplying power to the board. So this one, as you can observe, it has got two wires, both being live. This wire is supplying power to the board, whereas this wire is going straight to the thermal switch. So as you can see, it goes straight to the thermal switch, and one wire goes back and it comes out here, and this is the live wire that sends power to the compressor. So you can see that the live wire is coming out here, which is going to supply power to the compressor. So to supply power to the compressor, you connect this connector and the compressor connector. So as you can observe, the connector has got different shapes, which will help you to make the right connection. So that is how you place it in. And to remove it, you just press on the sides and take it out. So on this connector, you have these two wires that supply power to the start capacitor, which is located under here. And its value is 17.5 microfarads.
So moving on, I will explain to you the pneumatic system for the 1025 oxygen concentrator. So when you switch on your concentrator, the compressor takes in air from the environment. So the air first passes through the gross particle filter before it is taken to the fine particle filter, which is located over here. And from the fine particle filter, the air then passes through this tubing to the compressor. So after the air is compressed, it is filtered through this compressor filter and taken out through this tubing, which is connected here. So this is the heat exchanger tube. This heat exchanger tube takes the air over the fan and to the rotary valve. So at this point, the air is in the rotary valve. So the rotary valve is there to control the flow of air to either of the seatbelts. So it aids in the PSA process. So basically, in the PSA process, as one of the seatbelts is being pressurized, the other seatbelt gets depressurized. So for the seatbelt that is being pressurized, nitrogen gets absorbed as the air is moving through. Nitrogen gets absorbed and only oxygen is released to the manifold. And part of that oxygen is taken to the depressurizing seatbelt, where it aids in the purging of nitrogen. So when the rotary valve switches from this seatbelt to this seatbelt is the one that gets pressurized, as this one is being depressurized. So the oxygen will take the same route. It will go to the purge manifold, and part of that oxygen will aid in the depressurization of this seatbelt, whereas the oxygen from this seatbelt will go to the product tank. And from the product tank, the oxygen will be regulated with this pressure regulator going through the oxygen sensing device and out through this tubing. So this tubing is the one that is connected here at the flow meter. And through the flow meter, it goes through out this pipe to the bacterial filter. So the bacterial filter is there to filter out all microorganisms that may be present in the oxygen before it is taken out to the patient through this outlet port.
So I am going to show you how to remove the rotary valve. So in order to remove the rotary valve, we need to also remove the safe beds. So to remove the safe bed, firstly we need to disconnect this tubing, and remember to tape the opening. We tape the opening to avoid exposing zeolite to moisture. The next thing, I'm going to remove this cable tie. So I'm using a cutter. Then to remove the bottom hose grip, I am using a nut drive. And also remember to tape the bottom of the safe bed. Then I'll do the same with this safe bed. You disconnect. And you tape. disconnect the cable for the rotary valve. Then I'll remove the hose grip going to the muffler. To remove the exhaust muffler, I'll cut these cable ties. So this is the exhaust muffler. Then you can easily remove the rotary valve. So there's a link in the description below for a video that explains how you can disassemble the rotary valve, clean it, and replace it back. Now I'll start to assemble everything back. So I'm going to put the cable tie that will hold the exhaust muffler. And this is the exhaust muffler. Then I'll trim the edges. Now I'll connect the tube coming from the rotary valve to the exhaust muffler, this one. And make sure that the hose clip is tight, because there can be a leakage. Then next I'll connect the tube for the heat exchanger. So now I'll connect the safe beds. And also make sure that the hose clip is tight to avoid the leakage. So I'll do the same with the other seat bed. So now I am going to put back the compressor. flat screwdriver. So now I'll connect the intake for the compressor. So now I'll connect the heat exchanger tube to the compressor filter. Remember to put the hose grip. And do not forget to connect the power cable for the compressor. Remember the HEPA filter. Now remember the screws at the bottom, so you have to put them. So I'm using the T-spanner number 10. Now let us put the front cover.
So to properly put back the front cover, first we have to put back the cables in their respective positions. So this is the cable to the reset switch. This goes to the on and off switch here. And the same with these two. Next, we have our tube that is leading to the flow meter.
Next, we have our tube that is leading to the flow meter. Then we can properly place the front cover in place. Next, you screw the two screws in the front.
So I'm using the T25 top ski.
Now I will put back the back cover.
exhaust particle filter goes here in the filter top. And you simply place it. And the last screw for the front cover. That is all we had for you on the DeVilbiss 1025 Oxygen Concentrator.
Don't forget to like and share the video and subscribe to our YouTube channel. Bye.